Here we're asked to find the inverse of the function. So first thing I'm going to do is switch this to y and then flip x and y. So I'm going to have 2y squared plus 3. Now I'm solving for y, so I subtract 3 from both sides. I divide both sides by 2. And then I take the square root of both sides to get rid of that y squared. So y is equal to the square root of x minus 3 over 2. Or if I wanted to be nice and fancy, which I do, I got f of x with the inverse of -1 there is equal to the square root of x minus 3 over 2. Now, verify using composition. To do that, I'm going to take this equation here, and I'm going to plug it into that x value. So I'm going to do this down here because I don't have enough room. But I got 2 times the square root of x minus 3 over 2 squared plus 3, right? So I just took this and I plugged it into this x value here. Now I'm going to simplify it as much as I can, and I should get down to just x by itself. So the first thing I'm going to do is PEMDAS. I do the exponents first. When I square this, when I have a square root and I'm squaring it, those two things go away. So really what I'm left with is this equation here. Now I'm going to multiply. So I multiply 2, and that cancels out this 2 here. And then I add these together. -3 plus a +3 is just x. So we're good to go. That is the inverse. Now, how do we restrict the domain to be able to find the inverse of this function? Well, really what we're doing here is that this equation here is a quadratic, and that quadratic is shifted up 3 units and then stretched. So really is going to look something like this. To restrict the domain, we need to find the vertex or the center and restrict it just to one side. So in this situation, the center is just at 0, and I'm going to just look at the right side here. So restricting the domain, I'm going to say that the x value has to be greater than or equal to 0. So that is my domain restriction of the original function. I always restrict the domain of the quadratic.